Why should we care about gravity? Well, gravity is the invisible force that keeps us grounded on this planet. It determines the weight of our bodies, the rise and fall of the tides, and even the motion of the planets in our solar system. To truly appreciate the world around us, it's crucial to understand this fundamental force. Now, the person who first gave us a mathematical understanding of gravity was none other than Sir Isaac Newton. Newton's equation of gravity, also known as Newton's law of universal gravitation, is a mathematical representation of the force that exists between any two objects in the universe. Newton's equation of gravity states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Sounds complex, right? But don't worry, we'll break it down step by step. To begin, imagine two objects in space. These could be anything from two apples to two planets. According to Newton, there's a force of attraction between these two objects. This force depends on three things: the masses of the two objects and the distance between them. First, consider the masses of the two objects. Newton's equation tells us that the gravitational force is directly proportional to the product of these two masses. This means if you double the mass of one of the objects, the gravitational force would double as well. If you triple the mass, the gravitational force would triple, and so on. Now let's talk about the distance. Newton's equation tells us that the gravitational force is inversely proportional to the square of the distance between the two objects. This means that as the distance between the objects increases, the gravitational force decreases, and it does so rapidly. If you double the distance between the two objects, the gravitational force becomes 1/4 of what it was. If you triple the distance, the gravitational force becomes 1/9 of what it was, and so on. So in a nutshell, Newton's equation of gravity tells us that the gravitational force between two objects increases with their masses and decreases rapidly as the distance between them increases. To summarize, the key points about Newton's equation of gravity are: 1. It describes the gravitational force between any two objects in the universe. 1. The gravitational force is directly proportional to the product of the masses of the two objects. 1. The gravitational force is inversely proportional to the square of the distance between the two objects. In other words, the heavier the objects and the closer they are to each other, the stronger the gravitational pull between them. On the other hand, the lighter the objects and the further they are from each other, the weaker the gravitational pull. Understanding gravity, as described by Newton's equation, allows us to comprehend a fundamental aspect of our reality. It explains why we don't float off the Earth, why the moon orbits our planet, and why the planets in our solar system orbit the sun. So next time you drop something, remember, it's not just falling, it's being pulled by an invisible force that connects everything in the universe: gravity.